It's August the 28th, 2010, and we on our way up to the Squaw Mountain repeater site.
When you come up here, you don't know what you're going to find, so you have to kind of be prepared.
So what kind of test instruments do you have?
We have spectrum analyzers, signal generators, network analyzers. We have a service monitor, battery testers, voltometers of various types. Is that all of our guys? Well,
we're on the final stretch of the road now, and of course the rocks are more bumpy.
definitely made a big improvement on this road. Welcome to Shangri-La.
And the repeater hut comes into sight.
I took the front panel off that cabinet, Mike.
Okay. Well, this won't take long. We're just checking if it's there, it's there. I can't imagine it's moved. But you don't know because of lightning. Yep. Easier to do it now than off of a snow cap.
That's true. I've been up here, but RMRL took his call for their clump call on this repeater.
Oh, he solid key.
This was
Yeah, now this looks like duct type cabling.
Must have been nice living up here.
yeah.
Okay, there it is. I've never seen it.
These are the isolators, and you've got a 90-degree hybrid. And so what happens is the power goes through the 90-degree hybrid.
Right.
Half of it goes to the load, and the other half goes out to the antenna, which is this port right here.
Right.
And then you've got the same thing down here for this combiner. And then you have another hybrid that brings the two together.
Right.
And so every time you go through a 90-degree hybrid, you lose 3 dB of power. Half goes to the load, half goes on out. Okay, now, I gotta tell you a funny story. Everyone came up here, including the site manager, and they said, we don't have the key to this door lock. We can't open it up. I said, really? This is locked.
Whom you're saying Bill did that?
This is locked.
Or truth.
No, it isn't. Oh, we can take the transmitter and switch it to our antenna.
It's okay. But
Or the receiver, or both.
Well, the receiver
receiver's causing
receiver is the problem.
Okay, so we'll look at the passband on that.
what
Now, the
battery
repeater is a TKR 750 Kenwood. It's capable of 50 watts out. We run it at 25 watts for two reasons. One, we have the amp, and that's what the drive is. But also, if we go on emergency power, we drop off, and the repeater's already set at a lower power and uses a lot less current.
Okay.
This repeater was like a 2-month labor of love building this thing. Literally no expense spared, and I have to say the major sponsor on this corporation. They supplied cabinets and a lot of the stuff that went in here.
Come over and look at it.
N0WMX supplied the repeater. The amplifier that's up here is a custom built unit that I designed. We have a UHF control. And then we've got a lot of stuff motherhooded in here for a repeater operation because you can't get to the site for half of a year. We have dual power supplies on here. Let me disconnect this because this is just a pass cavity that's to take care of intermod. We have several of them on the system.
No kidding.
We have two Group 27 AGM batteries. Now these batteries are a little bit different than what you normally see because they're absorptive glass mat batteries. They're UPS batteries. They're made to go all the way to a 0-volt discharge and come back up. But these are the kind of batteries you have to run. We keep a heater on here in the wintertime, keep the room at about 40 degrees. Because as batteries cool, they have less and less storage capability.
Are
Just
these
some of the
12?
things you can
12-volt batteries in
12
parallel?
volts, and they're in parallel.
Okay.
We have a GPS 55 amp switch mode power supply that charges the batteries. As backup, I have a 6 amp supply down here. Now, if for some reason we were to lose this one, the batteries would still maintain a charge, you just won't be able to use the repeater as much. But that's just part of the backup on here. This is an AC wall wart that goes to the controller. If we lose AC up here, the repeater identifier will send the letters EP at the end, emergency power. That lets us know that we've lost power.
Okay.
Some of the things we put on the repeater up here, we have isolators on here, so any mixes that might be coming down the transmitter side go into a dummy load instead of mixing into the amplifier and causing intermod. These things run about $1,000, we put that in there. Let's see, Ron donated the UHF radio. We have microwave relays on the back here. So where you see where it says transmitter and receive port, we can select the community combiner, or we can select our own antenna that we have out here. This is in case there was an ice, a storm, you lost the main antenna, we can switch to the other antenna and keep the thing operational.
You said
So
you had
what are those lights? It says green lights on the combiner. I thought we were.
Well, both.
Right here it
well,
says
combined.
right now the receiver's on the combiner and the transmitter's on the combiner. I can give it a code and switch it to the duplexer, which is on the primary antenna.
You said we have a microwave link up here? Is that
But
what
we
you
have a
said?
UHF link, 450
Okay.
link.
So
that
the
comes up here.
UHF radios for the UHF.
And we can
link.
duplex through that, and that has priority. So if something was going on the input, we can come up on the UHF side and override whatever's on the VHF side.
This thing is really built to.
Nice.
The whole cabinet is wired here for lightning protection, grounding bars. We've gone to the nth degree. We have polyphaser units here on all the antennas that are coming in. We have a bandpass filter here for the UHF side that takes care of it. So we're going to get started. What we're going to do is we're going to look at the VSWR going out to the antenna. We're going to look at the tuning on the cavities. We're going to take the watt meter and we're going to go over to the combiner and look at the power going into the combiner and the power coming out, just to make sure that it is what it should be. These are things that haven't been done. We're going to look
Take
at
some
the
pictures
tuning
with this
on the cavities to make sure
Just snap
that
away.
the passband and the anti-resonant notch, which is on the opposite frequency, are where they should be. There's a spectrum analyzer and tracking generator.
What's the manufacturing model number?
This is an Agilent ESM 4402. It goes up to 6 gig. What we're going to do with this, we'll set up a reference signal, and then we're going to look at the passband tuning on this cavity.
Two pieces, so it looks like the top half is what's turned.
Top half turned. Yep.
Right at the juncture up there.
Yep. That's what turned.
Well, that's bolted together. It shouldn't.
Well, it's all bolted together.
Well, the Yankee was definitely supposed to be pointing at Denver proper.
West,
Yeah.
West is that way.
We did that.
Wave to the camera, Charlie. Don't drop the wrench.
Yeah, don't fall.
And a bunch of them are pointing
Yeah,
up
you
the
can
direction.
pretty much figure out everybody knows where Denver is. It's been up on that tower.